Okay, our next section deals with absolute value. I don't believe you've done anything with absolute value, so. Absolute value is a really simple, real simple concept. Absolute value is the maximum distance, the positive distance you are from zero. So what that means is simply this. The symbol for absolute value is two straight line brackets. Okay? So basically all that says is how far from zero is negative 3? 3 units. The absolute value of negative 3 is 3. The absolute value of 4, how far is it from 0? 4. So that's basically all absolute value is. It turns any negative value into a positive. Okay? Now, when I look at it in terms of what are possible solutions, well, if I have the absolute value of x is equal to 4, what are my possible values of x? Exactly. So what I do is I solve it by going x can equal 4 or x can equal negative 4. Very simple concept. Alright? So if I take something like this, x plus 2 is equal to 6. Alright, what are the possible values here? Well, to solve it, I go x plus 2 equals 6, and I go x plus 2 is equal to negative 6, because it can be either positive or negative. Therefore, x can equal 4 or negative 8. There you go. Okay? Pretty standard, right? So let's follow through your working example. What's the absolute value of 25? Absolute value of 25? 25. What's the absolute value of negative 8? 8. Done the first one. Okay? It wants us to write the following real numbers in order from least to greatest. Okay? So I have the absolute value of negative 10.1. What is that value? 10.1. Then I have absolute value of negative 21 over 2. What would that be? 10.5. It's a positive. Then I have negative 9.8. Then I have the absolute value of 10. Negative 10. Negative 9.9. The absolute value is 9.9. 9 and 7/8. What is 7/8 as a decimal? Anybody do that?
0.875.
Yeah.
What?
Punch it in. This is one you should know, actually. 125. And then 0.25 and then 0.3. It goes up by 12 and a half. So yeah, that's right. And then the last value is minus 9. Okay, so now we have to order them. Now that we got rid of all our absolute values, you order them from the least to the greatest. Well, what's the smallest number on the board?
Negative 10.
Negative 10. And then?
Negative 9.8.
Yep.
Negative 9.
Okay.
And then 9.
Looks like 9.8.
Yeah, 9.8. And then 9.87.
No, we don't have 9.8. It's a negative 9.8. So it'd be negative. It'd be 9.875, 9.9,
10 and 10.1.
10, 10.1, and 10.5. Right. There you have it. Okay. Again, the focus on the concept is: can you change an absolute value to a positive number? That's all you got to do.
But why does negative 10.1 change to 10.1 and negative 9.8 stays negative 9.8?
Because there wasn't an absolute value around negative 9.8. Okay. All right. Evaluate. Absolute value of 5 subtract 6. So write this out in your book. What's the absolute value of 5 subtract 6? Well, what's 5 subtract 6? Negative 1. What's the absolute value of negative 1? 1. There's your answer.
So whatever's in the bracket, you just do the opposite of?
No. You make it positive.
Okay, you make positive.
Okay? So I have the absolute value of 2, which is 2. And I gotta subtract 3 times negative 4, which is,
-12.
and the absolute value of negative 12 is
12.
12. So what is the solution? Negative 2. Okay? Alright, absolute value. 5 times, what's negative 2 squared? 4. Plus 7 times negative 3. Negative 21. Subtract 15, all absolute value. 5 times 4 is
20.
20, subtract 21.
-1.
Negative 1, subtract negative 15.
-16.
Absolute value negative 16, which is
16.
16. Okay, it's mental math. I know I lost some of you. Just doing it quickly. But, I mean, you do have your calculators, because you probably need them to do that. It's not cool, but it is life. Okay? Got a question about it? Tell me what's the problem?
Nothing?
Why are you looking at it like it's different language? Follow? Okay. Alright, the last one then is on the next page. Factors no more. That's all of 7.1. Pretty simple, right? Okay, so I'm going to show you 7.2. Alright, we're going to take it one more step. But it again is simple. So don't get worked up over this. First things first, let's review how to graph a line. Okay? Y equals
-15.
2x subtract 4.
-4 is your 1.
Okay, so let's go to 0 and negative 4, because that's my starting coordinate. 1, 2, 3, 4. 0, negative 4. Where does my map tell me to go?
Up to left 1.
Up to like
Right
Up
1. sorry.
to right 1 to right here. Okay, so far? Alright, and I draw my line through there. Alright, now, first thing I want you to do, okay, because we've got the y-intercept already. What's the y-intercept?
-4.
Negative 4. What is the x-intercept here? How do I find it? You're right.
2 times 2 subtract 4 is 0.
Okay, so, yeah, alright, you did the math part perfectly well, but how do I find any of the intercepts? What do I do?
Choose on 0 and for y and so on.
0 for y or 0 for x, right? In this case, I want the x-intercept, so I put 0 in for this, 2x minus 4, 4 equals 2x, and as Isaac said, x equals 2. So far, so good, right? Okay, now it says f of x. Okay, we're going to start using that notation again. That means it's a function. That's all it means. Pass the vertical line test. F of x is y, right? Is the absolute value of 2x minus 4. So now I want the absolute value of that graph. So what has to happen here? I graph the 2x minus 4. Done. Now all that I need to do is, what can the y values not be? If I've got an absolute
2.
value,
So,
it can't be negatives. The y values can't be negatives. So they all become positive. So the graph of the absolute value of this, all I do is graph the original, which is 2x minus 4, and then where it hits this point right here, So there's still, that's all part of it. All my y values there are positive, they stay positive. But for example, I have 0, -4 right here, right? Okay? Well, if I put 0 in for x, what do I get? 2 times 0, which is 0. 0 subtract 4 is? What's the absolute value of -4? +4. So actually, it's right here now. So I take this line and I reflect it up, or we flip it over the axis. There's my graph. That's all there is to it. So all that you need to do is change all your y values to positives. So wherever they're negative, they're now positive. The y values, meaning everything down below this axis. That's where the y values are negative, correct? Y is negative down here, yeah? Right? Now they all become positive. There's the graph of f of x equals the absolute value of 2x subtract 4.
So what do you do if your, your y-intercept is positive?
Excuse me, person Sydney LeBlanc,
Stays
to
as
the
is.
office, please, Sydney LeBlanc.
Wherever it's positive, it stays as positive. It doesn't change. Okay? So far, okay? Alright? So I'm going to show you a little bit more dynamic one, which is an x squared one, a parabola, because it has a funny looking shape to it, but it's fairly straightforward. So we are going to graph f of x equals the absolute value of x squared minus 4. Okay? So we're going to graph the original. And by the original, I mean what's in the brackets, what's inside the absolute value. So it's x squared subtract 4. What's my vertex for x squared subtract 4? Nope.
It'd be 4. 0.
Closer. Okay. How we forget things.
Plus 2 minus 2.
All remember this? Vertex form. You did it in applied. You've done it in pre-calculus. Do we remember vertex form now? What's my h and k? What do they represent? My vertex. H and k is my vertex. What is h and k in that first equation?
4.
My good, like seriously. What is h?
0.
0. Is there anything in brackets here? So what is h? 0. What's k? -4. Again, you're going to have an exam on this in about 3 weeks. And there's a lot of that on there. So we've got to start getting this stuff processed a little bit better. So my vertex is 0 and -4. 1, 2, 3, 4. Down here. Does it open up or down? Can you tell me that? Why?
Because there's no negative. It's a positive, so it's a...
Okay. Alright, now, as it turns out, my intercept points are 2 and -2. Put 0 in for y, add 4, take the square root, so you get plus minus 2. Alright, so there's x squared subtract 4. You have to do that without the help of technology. If it's in vertex form, you got to be able to draw that. Alright? Now, I want the absolute value of this, which means I don't want any y values being in negative. But the ones that are positive, stay positive. So this stays like this stays like this, and this on the bottom flips up. So down here comes up here. There's my graph. all you do is take the bottom and flip it over top, like you're folding a piece of paper. And that's what it would end up being. All of these negative values for y right here, they all become positive right there. This is what we call absolute value. Now we get into it where we've got to talk about what parts of the graphs and piecewise, but we're not going to get into that just yet. I want us to get this part down first. So let's look at the first working example. You need to follow through in your book with this. Consider the absolute value of the function y equals the absolute value of 3x minus 1. Okay. First thing it says is determine the y-intercept and the x-intercept. So when x is 0, what is y?
Negative 1. Like 3 times 0 is 0 minus 1 is negative 1. So
And what's the absolute value of negative
Excuse me,
1?
Ms. Joseph, Ms. Newhopper to the office, please. Ms. Newhopper?
Plus 1,
okay.
because of the absolute value. Okay. All right. Now, the y-intercept, put 0 in for y. Is that? Sorry, that's the x-intercept. The x-intercept is 1/3 and 0. Okay? Now, they want you to do that because then you plot those coordinates and graph it. But we're going to graph it the way we've always graphed it. What's my starting coordinate? My coordinate. 0, negative 1, that's right, right there. 0, negative 1. And where do I go from there? 1, 2, 3, 1, right, right. Positive is right. This is positive. This is also right. So it's always that, right? Okay. So now, to get the absolute value from this 1/3 part right here, up here, it all stays the same. Okay, so from when x is greater than 1/3, those are already positive, so they stay that way. So all my x values, this point right here is 1/3 and 0, right? We just figured that out. So all the values over here, all the x values over here, my domain is greater than that, they all stay there. But what happens to all of these ones? What do I do with this guy? I just flip it up. So it's going to go through right here. I'll do that in green. There we go. There's my graph. Okay? The absolute value of 0 is 0, so it stays right there. The absolute value of negative 1 is positive 1, so you flip it and you go through that. What is the domain for this graph?
X is now in the all rows.
Yes. And what is the range for this graph?
Y is greater than or greater than 0.
Yes. Y is greater than or equal to 0. What's the lowest point on this graph? Right there, right? What is that coordinate? 1/3 and 0. So therefore all my y values are greater than that. Okay? The last part, it says express it as a piecewise function. I'm going to worry about that tomorrow. I don't want to worry about that right now.
So the first y-intercept that you find when you're following that graph is not the absolute. The absolute is when you take the opposite of that one. like 0 and -1 is what you graph first, but then you have to take the absolute of it to find the actual one.
Yeah.
So that's what you flip. So do you have to draw the first one, like 0 and -1 there? And then flip
Well-
it, or can you just draw like 0 and 1?
Yeah, okay, I see where the confusion is.
Because,
I wouldn't, okay, so this is kind of a check for us. Does the graph at the absolute value, does it go through 0 and 1? It did, right? I'm just checking with that. But when I graph the original without the absolute value, the 3x minus 1, that was this line.
Yeah.
It goes through 0 and -1. But when I put the absolute value on it, I flip it,
okay,
okay? So then that checks to make sure that I've gone through that coordinate with this graph. That's why I don't like what you did. I wouldn't do it. I would just graph it the way we always graphed it that way. Okay?
and then just flip it.
Yeah. I draw the original all the time here. And the other reason I do that is because when you get into grade 12, we do reciprocal functions and we do absolute functions, and we do always draw the originals first before you put those values on there. Okay? That's good enough. You got the rest of today to finish 7.1 off. It shouldn't take you very long to do it. And I'll go through 7.2 with you tomorrow and talk piecewise.